Okay guys, I am sitting in Africa and I know you guys already have your notebooks out and you are ready to take notes on inverse functions today. Remember that if I start going too fast or if there's something I say you don't understand, just ask Mr. Chavez to pause the video. You may get caught up, you may ask questions, just whatever you need to do. Okay, I've titled this inverse functions, but I do want you to understand that not all inverses are going to be functions, okay? And what we are doing is we are looking at inverses of relations, actually. So the definition of an inverse is the reflection of a relation over the line y equals x. So there are a couple of things here. First of all, remember that a relation is just a set of ordered pairs. It's any group of ordered pairs. All right? Reflection, you know what that is. It's when we flip it. Okay? Over the line y equals x. What do we call the line y equals x? No, seriously, answer. I expect everybody in the room to answer. What do we call the line y equals x? Exactly. We call it the linear parent function. So, I'm sure you guys remember that the linear parent function looks like, oops, not quite like that. It cuts the first and third quadrant exactly in half. And every point on it, the x and the y are exactly the same. So that's the point 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2. So our inverse function is going to flip over, reflect over this line. It's not reflecting over the x-axis, it's reflecting over this line. So we've got to play with this a little bit and make sure that we understand what that means. And that's what we're doing today. Now, if we have a relation and we call it relation y, if this is the original relation, then its inverse is going to have the notation y raised to the negative 1. We call that y inverse. Okay? If our original is called f of x, the notation for its inverse is f inverse of x. Now, these are not exponents. These are notation to say this is the inverse of something else. All right? Since we are reflecting over the line y equals x, a great little thing to be aware of here is that really all we're doing when we find the inverse of a relation is switching the x's and y's. Now let's think about that. What do we call the x values in an equation or a relation, a table? What do we call the x values? No, seriously, everybody answer. What do we call the x values? Correct, domain. And what do we call the y values? Everybody? Range. Very good. Hope you guys aren't making a fool of me. I hope you're answering. All right, so moving on. We can find an inverse using a table, a graph, or an equation. So let's start with the table. This is going to be really nice and simple. So if we're given a table that represents either a relation or function, remember a function is just a relation where the x's do not repeat. Okay? So as we look here at this relation is a function because none of my x values repeat. To find the inverse of a table, we literally are going to switch places between the x and the y values, or the domain and range. So my x values are now going to be these values: 7, 3, negative 1, negative 4, negative 7. Those are the x values of f inverse. These values are now my y values of f inverse. So negative 1, 1, 3, 5, 7. It's that simple. This is how you find the inverse of a table. Now let's go ahead and find the domain of F inverse. Now remember, because all I have given you is a table, how are we going to list our domain? We are just going to write the actual numbers in the X column. We are not doing an interval because all the numbers between 7 and 3 are not included. All the numbers between -4 and -7 are not included. So the range of this relation, F inverse, is -1, 1, 3, 5, and 7. And yes, guys, it really is that simple. So let's look at this. I want to graph both the original and the inverse on the same graph, okay? So what I'm going to do here, I'm going to go ahead and erase my domain and range and put a grid here so that we can graph it. Alright, I may actually end up plotting points on some of my table, but we'll deal with that. Okay, so let's first plot f of x. I've got the point -1, 1, 2, 3, 4, 5, 6, 7. There we go. I have the point +1, 3. I have the point +3, -1. +5, -4. Oops, sorry, that's not very much of a dot, is it? And then +7, 3, 4, 5, 6, 7, -7, 1, 2, 3, 4, 5, 6, 7. Now, am I going to connect these? Waiting for an answer. Am I going to connect these? You are correct, I am not, because they are specifically listed as points. It is not an equation, so I do not connect them because the points in between them are not actually part of the function. Now, because we defined an inverse as a relation that reflects over the line y equals x, I'm going to draw in my line y equals x right through my table. Oops. Y equals x. Need to go ahead and extend that down. Yes, I know it's crooked. Alright, I'm going to go ahead and label this one f of x. Now let's go ahead and graph our inverse. So my inverse is the point +7, 1, 2, 3, 4, 5, 6, 7, -1, +3, +1, -1, +3, 1, 2, 3, 4, -4, +5, 1, 2, 3, 4, 5, and -7, +7, 1, 2, 3, 4, 5, 6, 7. Alright, now I want you to see something. This point right here reflected to here. Do you see how it's the same distance off of the line y equals x? Oops. Sorry, I'm trying to get rid of that line. There we go. This point reflected here. This point reflected over here. This point reflected here. This point reflected here. Are you seeing the reflection? Okay, that's what an inverse does. Now, this is going to work with tables, whether they are vertical tables or horizontal tables. So let's go ahead and do a table this way. I bet I can't actually write that small with my stylus. Okay. 1, 2, 3, 4, 5. Okay. Alright, so if this is my f of x, then f inverse of x, remember I'm going to take my y values and put them in my x list. -5, -4, -3, -2, -1. Then I'm going to take my x values and put them in my y list. 1, 2, 3, 4, 5. Okay, so here is f of x plotted in green. So let's plot f inverse. I'm going to negative 5, 1, 2, 3, 4, 5, positive 1. I'm going to negative 4, positive 2, negative 3, positive 3, negative 2, positive 4, negative 1, positive 5. Can you see the reflection over the x equals y axis? Sorry, that line is not very good. Okay? All right, that's how we do a table. Now let's look at, well, we've done the table and the graph. Okay? So you now see how to do an inverse if given a table and how to do an inverse given a graph. Now, if you don't have the table and we're just trying to find the inverse using the graph, what I tend to do is I will take a point and I will gauge it off of the line. 1, 2, 3 diagonals off of that line, so I need to go 1, 2, 3 diagonals off of the line and put that point. Does that make sense? And Mr. Chavez, you might want to show them with a few more examples a way of doing that with the graph. All right, let's go ahead and go on to equations. All right, so we're given an equation, f of x equals 3x plus 7. First thing I'm going to do is I'm going to replace the f of x with a y. The next thing I am going to do is I am switching my x and my y. Okay, I literally, everywhere there was a y I put an x, and everywhere there was an x I put a y. Okay, so first step, switch x and y's. Okay, second step is solve for y. So your y is in a new place now, so let's solve for it. So I am going to subtract 7 from both sides. I get x minus 7 equals 3y. Now I'm going to divide both sides by 3. I get y equals x over 3 minus 7/3. We can leave it like that. Now, what this tells me is that f inverse of x equals x over 3 minus 7/3. F of x was 3x plus 7. Okay, so now instead of adding, I'm subtracting, and instead of multiplying by 3, I'm dividing by 3. It's inverse. Okay? So that's a nice basic equation. Let's look at one that's a little bit more involved. Okay, it looks uglier. Process is the same. I'm going to rewrite y equals x divided by 3 plus 2. Then I am going to put an x everywhere there is a y, and a y everywhere there is an x. Oops, I'm going to run out of room. Now I'm going to solve. So I switched. Now I'm going to solve. So minus 2 minus 2, x minus 2 equals y divided by 3. Oh dear, how do we get that 3 out of the denominator? Remember that the fraction bar is just division, so the opposite of that is, what is the opposite of division? Go ahead and answer. Opposite of division is multiplication, so we are going to multiply by whatever is in the denominator, because 3 will go into 3 one time, and I am left with 1y. Over here, we have to distribute. So we get 3x minus 6. So f inverse equals 3x minus 6. And we're done. All right, so I've got some practice problems for you that Mr. Chavez is going to hand out. If you need some more examples, ask him to show you some more examples. Get that practice in today, and tomorrow you will have an assignment on it. Can't wait to see you next week, guys. Do good.